All right, so what we got for you here is we have a Peltier cooler, and it's what it is you have input voltage, and it comes into this device, and it has a cold and hot side. So this side here with this label is the cold side, and the side with the heat sink is the hot side. So these are typically used in like computer systems, and like hobbyists use them for projects. Some of the YouTube videos I saw where people make like desktop air conditioners or little refrigerators. And today we just want to kind of share with you like some of the properties and like how this thing works. So what, like I said, you've got hot side. So on this side we have the heat sink, and what the heat sink is doing is dissipating the thermal energy in order to make it to where there isn't a super hot side. So, because like whenever you just power this up, there's one side that's really, really cold, and the other side feels like it's burning your hands. And so what the heatsink is doing is trying to help to where it's not as hot. So it's breaking it up and down these fins. So I guess what you can do, so see, you can measure this here, and this is about, so you can see this is about 70 degrees. So it's just over room temperature. But the one thing that about this setup here that we have for you, we've got another setup over here, is this really ideally you should have a cooling fan to help pull some of the heat out. Because right now, like I said, there should be a cold side and a hot side. And as you can see, it's just over room temperature. See, it's not like there's nothing to pull the heat out and like, you know, to pull it through from the Peltier cooler into the heat sink and into the atmosphere. It's just staying right here. So there's really, with this setup, there's really not a hot or cold side. So we'll move on to this other over here, and I'll show you our other setup. So this is just what I was talking about. It's exactly the same thing that we have, except we have a cooling fan. And what the cooling fan is just bringing that thermal energy and releasing it into the atmosphere. A lot easier than without cooling fan. So first thing what we did in our analysis is we measured the properties of the heat sink. So such as length, width, and fin thickness. And with that, we can come up with the area of a fin. Then with that, what we learned in class is known as the snake property, which is non-dimensional. We used it in a chart in the book to find the fin efficiency. Also, we used this to measure the temperature of the room and at the base of the fin. And with that, we could calculate the maximum heat flow of one fin with the fan. And with that, and with our fin efficiency, we could calculate our Q dot actual of the fan, and with the fan. And then the next step, we went from there, is we multiplied it times 9, so we could find our heat transfer rate, or our heat flow rate, with the entire fin heatsink system. So we wanted to go a little bit farther from there, and we found some aluminum properties, such as the thermal conductivity, which is 137 BTUs per hour per foot per Rankine. We found the heat convection or heat transfer convection rate, and it's 8.8 BTUs per foot squared per Rankine. And we found the heat capacity of air to be 0.24 BTUs per pounds mass per Rankine. So with that, we wanted to find the mass flow rate of the air. So we found our Q dot, the actual with the entire setup, the 9 fins. And by doing so, you can take Q and divide the heat capacity and the delta T, the change in temperature, from that, and you can calculate your mass flow rate. And from there, what we did is we went and we're like, okay, let's see what our your volumetric flow rate is. And with that, we found it to be 141.63 cubic feet per hour, or approximately 0.04 cubic feet per second. But the big thing from this whole entire analysis is we wanted to see what is the fan doing as far as heat transfer. How much is it really helping? Well, the fan, with having the fan, it's removing an extra which, or actually it's removing 1.33 BTUs per hour. But if you measure temperature here versus what we were getting over there, see on the Peltier cooler, where we're getting around 72, whereas here we're getting 35. And all of it has to do with this fan, which is helping remove heat from the heat sink and the Peltier cooler. And that's pretty much the gist of our system and what we've studied. As you can see, it is really helpful to have the fan in the system. And that's the analysis of Peltier coolers. Thanks.